For today's video, we are going to be solving absolute value equations. And you can actually use absolute value equations to find the distance of a bridge. And we have an example of Sydney Harbor Bridge. Later on in the week, we're actually going to do an example where we're going to find the distance of the entire bridge by using absolute value. Okay, so let's go ahead and recall some information about absolute value. You learned about absolute value sometime in middle school, and let's recall that information so we can use it for our lesson today. So recall that the absolute value of a number is that number's distance from 0. That's how we can use it to find the distance of a bridge. On a number line, for example, the absolute value of -5 equals 5, and the absolute value of +5 equals +5. So absolute value is kind of like a magical machine. You could take this machine and put any negative number you want on the inside. So I'm just going to put -x because x can represent any negative number on the inside. And this magical machine is going to turn it positive. So it'll be a +x. It also can take any positive number, so we'll put +x in there. Any positive number x, and it makes it remain positive. So absolute value is like a positive machine. Now, as you can see, here's an example of taking the distance from 0. Here's 0, and we have 5 units here, and we're given those numbers +5, and another distance from 0 could be -5, and that's why we have the answer as -5 right there. For any non-zero absolute value, there's exactly 2 numbers with that absolute value. For example, 5 and -5 have the absolute value of 5. And to write this, we can use an algebra statement. You can write this as absolute value of x equals 5. This equation asks you, what values of x have an absolute value of 5? Well, the solutions would be +5 and -5. Okay, here we are going to talk about the 3 steps to solving an absolute value equation. And this table kind of summarizes those steps. Well, first we're going to use inverse operations. We've been using inverse operations this entire time to isolate the absolute value. So that means we want to get the absolute value alone. It's really important. Number 2, we're going to rewrite the resulting equation as 2 cases. So we're going to be doing 2 cases, a positive case, and can you guess which other case could be? Take a minute or a second. Yep, negative. It can also be negative. So we're going to take a positive case and a negative case, and then we're going to solve the equation in each of the 2 cases. So we're going to create 2 cases and solve each case. This is why we had to learn how to solve equations in the beginning to the middle of chapter 2. Now let's go ahead and look at an example. We're going to be solving the equation, absolute value of x equals 12. But we're going to be solving this equation for x. So what values, and this is what you have to kind of think of. Remember, all the steps are in blue to your right-hand side. Think about what numbers are 12 units from 0. Well, if we look at this number line, we can first picture where 0's at. So 0's right in the middle. And then 12 units from 0 would be +12. And 12 units from 0 on the other side would be -12. So to show this mathematically, or excuse me, algebraically, we would say, well, case 1 would be the negative case. So x equals -12. And case 2 would then be the positive case, so x equals +12. And this is our final answer. So notice we have 2 solutions because there's 2 values for x that it could be in the absolute value, -12 and +12. Here's our next example. This one's a little bit more complicated. We're going to have to solve the equation. Here we have 3, absolute value x plus 7 equals 24. Make sure that you copy down the steps to the right-hand side. They're important steps to have. But we're going to go ahead and solve this. I'm going to go ahead and enlarge the picture so that we can have more room to write the problem, and then I'll reduce it back to size so you can write down those steps if you like to. So here we have absolute value. And the first thing we need to do to solve this absolute value is isolate the absolute value. So notice that right now we have this 3 right here, and I need to get rid of that 3. So to get rid of it, I have to use the inverse operation of multiplication. So we're going to divide both sides by 3. Here the 3's cancel out or reduce to 1. And now I had absolute value of x plus 7 is going to equal 24 divided by 3 is 8. So now that my absolute value is isolated, notice there's nothing around it, right? I'm just going to write around. So you see that there's nothing around there. There's nothing being added or subtracted. It's isolated. Well, now we are going to go ahead and create our 2 cases. So this is the way I think about it. This absolute value bars tells me to do this in the 2 cases, okay? The first case is going to be the negative case, so x plus 7. And you notice I'm not changing what's on the inside. I only change my answer. So now it's going to be negative 8. There's my negative case. And then I'm going to do my positive case, which is going to be x plus 7. Notice I don't change what's on the inside of the absolute value, and that's going to equal positive 8. And now the third step tells me just to solve each case. So I'm going to go ahead and solve my case 1 by subtracting 7 to both sides. The 7's cancel out to 0 here, so I just get x equals, and remember 2 signs are the same. We add it to make a bigger sign, so it's going to be negative 15. And then let's solve our case 2. We do the same thing. We subtract 7 to both sides. But now I have a positive 7, or excuse me, a positive 8 and a negative 7. So x is going to equal positive 1. And that is our final answer. These are both cases. And check your work. It's really easy to check. All you do is plug in that negative 15 and make sure it equals 24, and then plug in positive 1 in for x here and make sure it equals positive 24. So let me reduce it back down so that you can see that we use the same steps. So go ahead and write down this information. Pause it if you need to. Okay, I have a helpful hint for you. This is on checking your work. Be sure to check both solutions when you solve an absolute value equation. Remember I told you how important it is to check on quizzes and tests and on all your assignments. So if you notice, if my answer is going to be negative 4 and positive 4, I'll plug in negative 4 in for x. We'll see that that's going to equal positive 4, and 4 equals 4 is going to check off. I can also plug in positive 4 for x here. And then I still have my 4 over here. Positive 4 equals 4, which also equals 4, and that checks off. So you can do the same thing for the other examples on the previous slide and on the next slide. Okay, here is another equation, very similar to the last example that we solved. Notice how, and I'm going to go and enlarge it for you guys so that we can just focus on the problem, but I'll reduce it back to size so you can copy down the steps. So here we're going to solve the equation. Notice how the absolute value of x has this minus 3. This minus 3 right next to it. I need to get rid of that minus 3 before I split it into 2 cases. So I'm going to add 3 to both sides. Remember, if you forget what both sides are, you can just draw a line down the equal sign. And now this reduces to 1. So I get absolute value of x equals 3 plus 4 is going to be 7. And then those absolute value bars tells me to split it up into 2 cases. So the first case is going to be x equals negative 7. And the second case is going to be x equal positive 7. And that's your answer. You're done. Pretty straightforward. Let me go ahead and reduce it back to size so that you can copy down the information along with the steps on the side. There you go. Go ahead and pause it if you need to. Okay, we're all done with our examples, but I did want to discuss what happens when you don't have 2 solutions. All our examples had 2 solutions, but it is possible to have only 1 solution or no solution. So let's first focus on, and we're going to do this in red, let's focus on when there is 1 solution. When there's 1 solution, your absolute value expression is going to equal 0. So up top, I'm going to give you an example. I could have absolute value of x minus 5. Let's put a plus 6 equals 6. Now look what happens when I start to isolate this absolute value. I'm going to minus 6 to both sides. And then I'm going to get absolute value of x minus 5 is going to equal 0. Now 0 is the only number that does not have a positive or negative assigned to it. So we can't make two cases, which means you're just going to solve, and your one answer would be x equals 5. Now let's take a look at when you would have no solution. Well, no solution is when the absolute value is negative. Remember, absolute value can never be negative. So let me give you an example of when absolute value could be negative. I'm going to still do x minus 5. And I'm going to put plus and 8 equals 2. Okay, right now, whatever is over here is not negative yet because we have not isolated the absolute value. So if you minus 8 to both sides, you would get absolute value of x minus 5 equals negative 6. Now, can you think of any number that you could plug in for x right here that would give you a negative 6? Go ahead, take a minute. Try to think of any number. Okay, well, if you already thought of some numbers, I'm pretty sure there was no number you could think of that could go in for x that would give you negative 6 if you have some absolute value right here. So there's no solution for this. There's no way that you could find a value for x that you could plug in here that would give you negative 6 as your answer. When you come to class on Thursday, I will review some of these concepts over again. And for your stretch tomorrow, I'll give you some more examples so that you can try and practice these on your own. Have a good night, and I'll see you very soon.